Hey guys, circular motion problems are back with physics in the flesh. Let's do some Kepler's laws problems. Neptune is an average distance of 4.5 times 10 to the 9 kilometers from the sun. Estimate the length of the Neptunian year given that the Earth is 1.50 times 10 to the 8 kilometers from the sun on average. Okay, so this question is dealing with Kepler's third law. So as I've shown here, Kepler's third law shows us that the ratio of the periods of the two orbits of two different celestial objects squared is equal to the ratio of their average distances from the sun cubed. Now, if you are in astronomy, as I am, you'll know that when I just said average distance, that's technically not correct. This R actually stands for something called the semi-major axis. And the reason for that is planets don't actually orbit the sun in a circle, they orbit it in an ellipse. And there's two distances from the sun to that planet on one side, and on the other side, they're a little bit different. They're not the same distance. One is slightly longer. Regardless, you know, using the average distance, it's a fair estimate, okay? So let's see what we get. What I really like with Kepler's third law problems is that it's not like other physics problems where you have to put everything in SI units. For this one, you can put whatever units you want as long as they match up. So the R units can match up with the R, the T matches up with the T. That's it. Okay, so for this question, we're looking for the period of a Neptunian year. We know that the period of a year on Earth, we'll just call it 1 year. And because this is in 1 year, whatever answer we get for Tn, that's going to be in terms of Earth years. Okay, our Neptune, or the distance of Neptune from the sun, is 4.5 times 10 to the 9 kilometers. Okay, the distance from Earth to the sun, 1 astronomical unit, or 1.50 times 10 to the 8 kilometers. Okay, so that might not seem that much further away. Neptune, it's only one factor bigger, but that's a lot. That's 10 times further away. Okay, so here's Kepler's third law. What I would suggest is whatever you're looking for, which is Tn in this case, put that in the top left corner. Okay, that's the easiest way I can think of to solve it. Okay, so here we go. We're going to do Tn over Te squared. Now keep your numbers consistent. Because Tn I used as T1, I have to put Rn up here. Okay, so equals Rn over Re cubed. Okay, now I'm looking for Tn. So what I'm going to do is, you know that according to exponent laws, this squared is being applied to the Tn and the Te. Okay, so imagine we applied it to both and I wanted to get rid of the Te squared. I'm going to bring it to the right and multiply it to this expression right there. Okay, so therefore I can say that, you know what, let's move this up. I can say Tn squared is equal to Te squared times Rn over Re cubed. Okay, so hopefully you see that going. Okay, now I'm going to start plugging in my values. Okay, so Te is 1 year, and that gets squared. Obviously, you're just going to get 1 year back. Okay, for my R's, 4.5 times 10 to the 9 kilometers over 1.50 times 10 to the 8 kilometers. And this is all cubed. Okay, so hopefully here's where you realize that, yeah, this is why units don't matter, because notice the kilometers will cancel. Whatever you have, they're going to cancel because it's a ratio. Okay, so 4.5 times 10 to the 9 over 1.5 times 10 to the 8 gives you about 27,000, of course, when you cube that result. Okay, so then we get 1 year squared times 27,000, unitless number, okay? That's equal to Tn squared, don't forget. Okay, so 1 squared is 1, year squared is year. So pretty much we're left with 27,000 years squared. That's Tn squared. So to get Tn by itself, we have to square root both sides, which means we're going to square root the unit of years squared, which makes sense. We're going to end up with years. Okay, so Tn, you should end up with the square root of 27,000, which comes out to be 164. And because the question gave us a maximum or a least certain value of 2 sig figs, we must give this in terms of 2 sig figs. So I'm going to round it to 1.6 times 10 to the 2 years. Okay, so 1 year on Neptune is about 160 Earth years. Okay, so that's pretty long. Anyways, that's it for this video, guys. If you enjoyed it, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me.